Now we will see another measure of central tendency, that is our median. So median is the part of all the data values which divide those that array of data values into two equal parts. Okay, it is the central value, mid value, okay, that divides the data into two equal parts, right? So we will see this in case of group data as well as for ungrouped data with formulas. Okay, so before going to that, you have to know one thing, that whenever we are going to find the median for the ungrouped data, the data must be arranged. Okay, in all these measures of central tendencies, like you can say median as well as those percentiles, quartiles, deciles, in every case our data must be arranged, otherwise you will not get the accurate answer. Okay, now median for the ungrouped data, we have two formulas, two cases, that the number of values of our data can be odd if we, you can say, take the sum of just that how many values are occurring, what is the frequency of all the values. So if there are total odd number of values, like if you count all the values and there are total, you can say 17 values in your data, then that 17 is odd. So this formula is applicable, means n by 2th term, right? N by 2 into term. It doesn't mean that only n by 2 whatever you get is your median. No, the term at this position will be your median, n by 2nd term. Okay, and for the case of even number of values, this is the formula, like same as this one, n by 2nd term, second value, plus then the value next to this one, right, n plus 1 by 2 value, and then we take the average of these two values, that is divided by 2 gives us the average. But I guess these formulas are quite complex and we can go without these formulas by just simply analyzing our data. So we will not use these two formulas, we will directly do this. So see here how to do this. Okay, here you can see we are given an array of data or a combination of data, that is we are given 7 values, right? Number of values are 7, that is odd number, right? So without formula we are doing. Okay, the very first step is we have to always rearrange our data, okay, whether in ascending order or descending order. So you can see my data is arranged over here. Now we have to find the median without formulas. Now we know that median is what? Median divides data into two equal parts. Median is that central value of data that divides data into two equal halves. Now see here, which value is dividing data into two equal halves? It's not this 7 dividing data into two halves, like see this, the left part of data, that is 3 values, then see its right part, that is 3 value. It means that this 7 has divided this whole data into two equal parts. One part is this, second part is this, right? So the median is 7. This is the central value that is dividing data into two equal parts. Now this was in the case of odd number of values. In odd number of values you can directly easily guess which is our median, right? But when we are given the even number of values, see in that case what we have to do. This is we will also solve this without using the formula. So here you can see my data is already arranged. So now total number of values are 6, which means we are given even number of values, right? So okay, the data was not arranged, this 3 is still over here, which means data is not arranged, right? So we have arranged just like this, and now we have to find the median, right? Here you can see there is no any value that divides data into two equal halves. Like if you take this one as your median, then there are 2 values here and there are 3 values here, which is wrong. See over here we have, if we take 7 as median, we have 2 values here and 3 values here. So 7 cannot be our median in the case of even number of values, right? So now what we have to do, when we are given the even number of values, you have to find 2 mid values, right? Suppose if you take these two things as your 2 mid values, then these two together are dividing data into two halves, right? See here, this one is dividing this data into two halves in one half this is our one half, and this 9 and 3 is our another half, and this 5 and 7 are our mid values, right? So in case of even number, what we do, we take the average of the two mid values. So you can say, but because this was our unarranged data, so here in our arranged data, what we can do, this 5 and 3 is dividing data into two equal parts. This is one half, this is another half. So we take the mid, or you can say we take the mean or average of the two mid values. So 3 plus 5, that is 8 over 2, it gives us 4. So our median is 4. Okay, so you have seen that we have done this without using formulas. Just in case of even number, we take the average of two mid values, and in case of odd number, we directly can easily guess our median. Okay, this was for this case of ungrouped data. Now we will see for the group data. Here we have some, you can say another formula which we have to use for sure. Median for the group data. So here this L is definitely our lower class boundary. This H is the class width. We have seen how to find class width, how to find these lower class boundaries already. This F is the frequency, N means total number of values, and C means cumulative frequency. But one thing is that you have to put the C in value, C in this formula of the class or cumulative frequency of the class before the middle class, right? First we have to know what is the middle class. It is the class that contains the median. Okay, and before solving this formula, the very first thing you have to know is, out of all these data values, out of this table, which is our middle class. The very first step is finding the middle class, otherwise you cannot go further, right? So it is the class where our median exists. And how to know that where my median exists? Because you can see here we are not given the ungrouped data that we can easily guess, but we are given these intervals, so it is quite difficult to guess which is our median just from seeing, right? So we have to use some proper strategy for this. So what is that? How to get the middle class? Find the n by 2th value. This doesn't mean that you can simply divide the total number of values, that is 60 by 2, which gives us 30. So it means that 30 is our median. 30 is not the median, but the 30th value that lies at the 30th position will be our median. Okay, so in order to get the median class, we find n by 2nd value in the cumulative frequency. That's why making cumulative frequency in median is very important, but we don't need cumulative frequency for the sake of, you can say, in when we will be finding mod. Okay, there we don't need it, but in median cumulative frequency is very important. So we have to make the cumulative frequency column also. So for that, you can see over here our total number of values are what? 60. We are given total sum of all the frequencies give us a total number of values, that is 60. So 60 by 2 means 30th value. It means that I have to find this 30th value in the cumulative frequency column, right? It lies in 36. Here we can see, because this cumulative frequency ends at 19, it does not take values greater than 19, right? All the values greater than 19 fall in this class. Greater than 19 until 36 fall in this class. And since we got 30th value, so our 30th value is definitely going to be in this class, right? From, you can say, from 20 to 36, all the values lie in this class. We have seen this by the cumulative frequency, that which is our middle class, right? So this class is my middle class. It means I'm going to use this class for my formula. This is my lower class boundaries, right? So you can take it as a lower class boundary, and actually see over here we are given the class intervals. You can be confused by this thing. You can think that these are in points, because since you know that class boundaries look like this, right? But don't get confused, these are our class intervals, because you can see there is some gap. This is 10.7 and here we are not getting 10.7, which means there is some gap in between these two classes, a gap of some points, right? or you can say infinite gap exists. So these are our class limits. We have to find the class boundaries. We have to find all the class boundaries. I'm just dealing with this one that we need for our formula. So since our data is in decimal, so as I've told, the hint for finding the class boundaries was what, that you have to subtract 0.05 from the lower class boundary and add 0.05 in the upper class boundary, and we get this result. Right, so this is my lower class boundary, this is my upper class boundary, and this is my lower class limit, and this is my upper class limit. Right, but for the case of a formula we need the boundary. So this is my lower class boundary. Okay, so and this is, you can say, my cumulative frequency of this class. But we know for the formula in here, you can see this C means cumulative frequency before the middle class. Okay, so I'm not going to use this 36, I'm going to use 19. This is the requirement of the formula. So after putting all these values over here, you can see our formula was this one. We have to find put the lower class boundary. So my lower class boundary is 10.75. then h is what? It is the class width, that is 9.8 minus 9.3 gives you the class width. Frequency f will be of that particular middle class. N is the total number of frequency values. C is the cumulative frequency before the middle class. So after putting all those values, we get the median as 11.07. Okay, this was all for the median. And you can see I have also discussed about the model class, but this is about the mod. Okay, that the class with the highest frequency is the mod. We will see this in the very next lecture, so wait for that. So here, that's all for the median, for the grouped as well as the ungrouped data. So thank you.